Hello, folks. We're going to talk about percent yield and theoretical yield. For your definition, the big one is going to be theoretical yield. It's calculating the maximum amount of product. So in order to do this, we need to know what our limiting reactant is. That was the previous lesson, so that we know our starting point for our theoretical yield calculation. And then all we're doing is finding the product that we're asked for. You may remember these here. Our theoretical yield is our hot dogs and our bun. Our excess reagent is the one that didn't react. And this is if everything goes to 100%, but there's often reactions that don't go to that 100%. So oftentimes we don't get back exactly what we put in. If we're looking at our chemical equation here for water, we have those 4 water molecules. That would be our theoretical yield. And then we have our excess reactants in there as well. So pause here if you need to get that definition down. Another way to say this, the maximum product calculated from a balanced equation. So you should have that down in your notes already. Our actual yield is the amount of product obtained when the reaction takes place. So another name for actual yield is experimental yield. So that's what you're going to have in hand, whatever it is that your reaction was. Another word for theoretical is calculated. Calculated. So that is going to be from your reaction. So that's how they're different. The other thing you have to write down on this is your percent yield equation. And that's just going to be our actual yield, or the one we got from our experiment, or your data. And then your theoretical yield is going to be that calculated, because this is what you should have in a perfect world, right? We should always get back of 100% what we put in. This is what you did have. This is what you did get. And it's not a perfect world, unfortunately. And that times 100 just takes that ratio and turns it into a percent. So let's see how this works. We're going to go through an example that everybody, I'm sure, is familiar with. You need the actual yield, so you need experimental results, and you need the theoretical yield. Everybody's made cookies before, hopefully, or helped with making cookies. Recipes always say they make a certain amount of dough, right? In this case, it's 5 dozen cookies. So theoretically, 5 times 12 would give us 60 cookies from a recipe. While scooping the cookies, you must have made them big because you only fill 4 trays with a dozen cookies each. So you only made 48. 48 cookies are scooped. That's going to be actually what we got back from our experiment, right? So theoretically, the recipe should have made 60, but we only got 48. So we're going to put it into that calculation. Our actual or experimental yield was 48 cookies. We should have got back though, so that's theoretical or calculated from that recipe, 60 cookies. We're going to put that ratio over 100. 4 out of 5 dozen we could also use, and we get 80% yield. It's as easy as that, but of course it's not quite as easy as that because we're not going to give you the number of cookies all the time. So you might have grams, and you're going to have to calculate from moles. You're going to have to do that stoichiometry that we've been learning in order to get exactly what you need. Alrighty, so here's our first practice problem. You can pause here and we're going to go over it just a second, or feel free to continue watching. Just make sure you record the process in your notes. We have our balanced reaction, right? 2 carbon, 2 carbon, 2 oxygen, 2 oxygen. We want to know what is the percent yield of carbon monoxide when 30 grams of oxygen is the limiting reactant. So it tells us we don't have to figure out what the limiting reactant is because we know we have 30 grams of oxygen. These problems also have to tell you the actual yield. Unless you're doing the experiment yourself, you need to know how much they got back. So 40 grams is not going to be our given in this place. This is our actual yield, what we actually got back from our experiment. So in order to figure out our theoretical yield or our calculated yield, we have to start from our limiting reactant. That's going to be 30 grams of oxygen. Alrighty, in order to get from grams to moles, because when in doubt, always convert to moles, we have to go by the molar mass. We have 2 oxygens, so that's going to be 32 grams per 1 mole of oxygen. Remember, our conversion factor should be equal. Now we have to use that balanced equation to get from oxygen to carbon monoxide. There's 2 molecules or 2 moles of carbon monoxide made for every 1 molecule or every 1 mole of oxygen, diatomic oxygen. And then because they give us our theoretical actual yield in grams, we need to convert our moles of carbon monoxide to grams of carbon monoxide. So this is from our periodic table. Carbon's 12, oxygen 16. That's going to give us about 28. When we multiply everything on the top, divide by everything on the bottom, we get 52.5 grams that we should have gotten back. 52.5 goes on the bottom because that's what we should have gotten back. That's our whole. That's out of 100 there. 40 grams is what we did get back, and that was given in the problem. So we do our actual over our theoretical or experimental over calculated, either way you want to say it. Whatever helps you remember, times 100 gives us a 76% yield. Let's go through another problem. We don't have to find our limiting reactant because that's our product. So that's our theoretical yield. I feel like I did that last year when I was doing this too. Alrighty, so let's see the maths. We have our balanced reaction. We start with 5 grams of hydrogen to figure out what our theoretical yield is. This was given in the problem, right? So this is what our experimental was. We should have gotten back 28, so we got back 56, which is not a great return, depending on how efficient this reaction is. So why must a limiting reactant be used to calculate theoretical yield? Because you need to figure out the max, right? Alrighty. If you have questions, please make sure you ask them. Otherwise, it's time to go on to the practice. You have a choice this time between this worksheet here, or one similar to it, or the online textbook tutorial and practice. So I'll see you soon.